Hello, class. Today, we begin our study of the role of automatic input device for backup power supply. To understand the automatic input device for backup power supply, we must understand power system automatic security control equipment first. The so-called power system automatic security control equipment refers to the automatic devices that play a role in control to ensure the safe and stable operation of the electric power network when a fault or abnormal operation occurs in the electric power network, such as auto reclosing, standby supply, or standby equipment automatic input, automatic load shedding, low frequency and low voltage automatic load shedding, power plant accidents to reduce the output, cut machine, electrical brake, hydrogenerator automatic starting and phase modulation to generation, pump storage units by pumping to generation, automatic splitting, out-of-step splitting, and automatic regulation excitation and so on. We are going to talk about automatic input device for backup power supply. What is the meaning of automatic input device for backup power supply for substations or equipment with double or multiple power supplies? When the working power supply is disconnected due to a fault, the standby power supply can be automatically and quickly put into operation to ensure continuous power supply to the user's device, which is known as automatic input device for backup power supply, short for BZT. Let's briefly introduce the BZT with the following diagram. My substation has two bus bars, that is, first bus and second bus. Incoming line 1 is connected to first bus through circuit breaker number 11. Incoming line 2 is connected to second bus through circuit breaker number 12, and the connection between first bus and second bus is made by section circuit breaker number 13. In normal conditions, circuit breaker number 11 and circuit breaker number 13 are in the closed position, at which time the voltage on the first bus is supplied by the incoming line 1, and then the first bus is supplied to the second bus through section circuit breaker number 13, at which time both the first bus and the second bus are in the state of voltage, and circuit breaker number 12 is in the subposition. But there is a voltage on the incoming line 2, and therefore the incoming line 2 is a standby supply, as circuit breaker number 12 is in subposition. At this time, bus 2 and line 2 don't have a direct electrical connection. If the incoming line 1 faults, the incoming line 1 protection device action will jump, open the circuit breaker number 11. When the circuit breaker number 11 is disconnected, the first bus will be out of voltage, and the second bus is through the section circuit breaker number 13 by the first bus to provide the voltage to the second bus. Bus 2 will also lose voltage. At this time, the BZT will be acted upon, will be closed on the circuit breaker number 12. Bus 2 will restore voltage. As the section circuit breaker number 13 is still in the closing position, the first bus will also restore the voltage. At this time, the whole process is when the working power supply is disconnected due to a fault. That is, there is a fault in the incoming line 1, disconnecting the circuit breaker number 11, closing the circuit breaker number 12, the second bus and the first bus to restore the voltage to go into operation. And this device that closes the circuit breaker number 12 is the BZT. And what are the basic conditions that need to be met for the equipment to be installed with BZT? The incoming line 1 has voltage, and the incoming line 2 must also have voltage, and be powered by more than 2 power supply supplies, which work in the form of an open standby and a concealed standby. What is open standby? Open standby, one as the main power supply. The incoming line 1 in the figure is the main power supply. It gives the first bus and second bus for power supply. Incoming line 2 is as a standby power supply. Before the action of the BZT, the circuit breaker number 12 is in the sub position. The incoming line 2 is not giving power supply to the load in the normal condition. Therefore, the open standby is that when the system is normal, the standby power supply or standby equipment does not work and is in standby state. What is concealed standby? Normally, the 2 power supplies each carry a part of the load and stand by for each other, which is called concealed standby. Normally, the circuit breaker number 11 of incoming line 1 is in the closed position. The circuit breaker number 12 of incoming line 2 is also in the closed position. And the section circuit breaker number 13 is in the sub position, in which case the power supply of incoming line 1 supplies power to the load of the first bus, and the power supply of incoming line 2 supplies power to the load of the second bus. So, how do they stand by for each other? If incoming line 1 faults, the protective device of incoming line 1 will act to disconnect circuit breaker number 11. When circuit breaker number 11 is disconnected, the first bus will lose voltage. Then, the load on the first bus will lose power. Then, the BZT will close circuit breaker number 13, and the second bus will supply power to the first bus through circuit breaker number 13. That is to say, before BZT is activated, the load on the first bus is powered by incoming line 1, and the load on the second bus is powered by incoming line 2. If the incoming line 1 fault causes the protective action to disconnect circuit breaker number 11, then the load on the first bus loses power. At this time, the BZT will close section circuit breaker number 13, and the power supply will be given to the first bus from the second bus. After the BZT has been activated, the load on the first and second bus is carried by incoming line 2, and the load on the first bus is transferred from incoming line 2 to incoming line 2 for power supply. Similarly, if the incoming line 2 faults, the protective device action to jump open the circuit breaker number 12. The second bus will be out of voltage. When the second bus is out of voltage, BZT action to close the 13th section circuit breaker. At this time, the first bus will give voltage to the second bus. Then, the load on the second bus by the original incoming line 2 to the incoming line 1 for power supply. This is the mutual standby. These are the two working ways of BZT. In short, concealed standby is when the system is normal. The standby power supply is also put into operation. With the above explanation, it's clear what the role of BZT is. In the substation, BZT ensures that after the faulty withdrawal of the working power supply can be put into the standby power supply to continue to obtain power, quickly restore the power supply of the substation, and effectively improve the reliability of power supply of the electric power network. According to the technical code for relaying protection and security automatic equipment, in which case a BZT should be installed, let's make a brief summary. 1. The plant power supply of the power plant and the power supply used in the substation with standby power supply. 2. Powered by double power supplies, one of which is frequently disconnected at the standby power supply. 3. The step-down substation has a standby transformer or a mutually standby power supply. 4. Certain important auxiliary machines with standby units. Well, class, that's it for today's lesson. See you in the next class.